this video, we're going to look at this question. We have been given this diagram, and we have been given, this is a spring, and this is the M1 M2 by a string which is passing through a frictionless pulley. Here, this is the frictionless. Then we're going to find or to show that mu, which is the coefficient of friction between M1 and the surface, is given by this 2 M2G minus KH over 2 M1G. So this is this mass 2, this is the gravitational field strength, and this is the force constant or spring constant. This is H, which is this one, the displacement, and this is M1, and this is the same as this one G. So this is what we are going to do. Now we are told, so this one, to show that this is equal to this when the system comes to rest. So when this mass falls a distance of h coming to this point. So this is what we are going to do. Now, just from the beginning, we need to understand something. You know, when it is at this position, it has some potential energy. And this is a spring. A spring has got also potential energy. When it is stretched, there is the elastic potential energy. And this one, this is the gravitational potential energy by M2. Now, when the system, when this one begins to move, it is going to have also kinetic energy. But we're told to say the system is starting from rest, and when it comes to rest, meaning the starting point is at rest, then the end point is also at rest, kinetic energy will be equal to 0, because kinetic energy deals with motion. So for this, we know that energy can neither be created nor destroyed, but it cannot be converted from one form to another. So the energy that is going to be done in this will be simply the difference in the energy, the difference from initial to final will just be as a result of friction force. So we can say change in energy will be equal to the work done by friction force. So this one, we know that mechanical energy is equal to potential energy plus kinetic energy. So if we say change in, let's say change in mechanical energy. So we say change in mechanical energy. Let's just say change in energy will be equal to the change in potential energy plus the change in kinetic energy. Now, since the system is starting at rest, and also when it comes to rest, the kinetic energy initial, Ke initial, will be equal to Ke final, which will be equal to 0, because kinetic energy deals with motion. And here, so we can say this is 0 because it is the system is at rest. But for kinetic, for potential energy, we have two forms of energy. We have potential energy, elastic potential energy, and also, so let's say change in potential, elastic potential energy plus. We also have the gravitational potential energy. We have the gravitational potential energy. So we say change. So this is the change in energy. Now, when the system is at rest, before it is stretched, PE, elastic potential energy initial, is equal to 0. But when it is stretched, from when this one falls, so when this one falls, the distance of h, the spring is going to be stretched by equal magnitude as this. So we have the PE, elastic potential energy final, will be half kx squared. This is the formula, where k is the force constant or the spring constant, and this one is the stretched distance. And When this one, before coming to this, the potential energy, gravitational initial, this will be equal to mgh. We have, so this is m2 gh. When it comes to this point, h will be 0 and P final potential energy, the gravitational potential energy final will be equal to 0. And change in energy, we know that change in energy is equal to E final minus E initial. So we can plug in this information in this, and we're going to find that this one we are going to have half kx squared as the final energy for elastic potential energy minus 0, then plus the change in gravitational potential energy. We have the final as 0 here minus the initial m2gh. So this one we're going to have half kx squared minus m2gh. So this is the change in energy. So this equation, let us call it asterisk 1. Now, when we plug this asterisk 1 into this equation, this will be equal to, then when done by friction force, it is actually F, which is friction force times displacement. But we know that work done by friction is a negative work. So we can say half kx squared minus m2gh is equal to, so here we have negative F friction force times displacement, which is equal to x or simply h, or let's just say x. It is fine, because so the distance from here, when it is stretched, x will be equal to h. So this is the same. So from this point, we know that friction force is given by F is given by mu n. And for this mass, so if we've got something like this, then there is a force that is dragging in this direction. Then here we have the weight, which is mg. Then there is the balancing force, which is the normal force. Then in this direction, if the force is going in this direction, then friction force is in this direction. So it is perpendicular to the normal force. And this one, from Newton's laws of motion, and so the summation of forces in y must be equal to 0. So this one must balance with this. So n minus mg is equal to 0. So n is equal to mg. So where there is the n, we can put mg. So friction force is equal to mu mg. And since we are talking about m1, it is this one. We want to find this one. So we can say mu m1g. So plugging in this, we have half kx squared minus m2gh. This will give us negative mu m1gx. But we know that h is equal to x. So where there is x, we are going to replace by h. So we have half k h squared minus m2gh is equal to negative mu m1gh. Since we want, at this point, we can even multiply throughout by 2 so that we get rid of the fraction. So we multiply by 2 and we're going to have kh squared minus 2 m2gh is equal to negative 2 mu m1gh. But you see that h is common, so we can factor out h, or we can just cancel this, and this. And what we're going to have is in, we can divide, from this point we can divide it through by negative 2 m1g, also here by negative 2 m1g. Now, at this point, we see that this and this will go, this and this will go, this and this will go, negative and negative will go. So this is the same as writing as, so we say negative kh minus 2m2g over 2m1g. So this is equal to mu. And this one, so we can distribute now the negative, so we have, and if we are arranging the equation, we have mu is equal to, so this one will be negative, this will be positive, so we have 2m2g minus kh over 2m1g. So this is the expression for the coefficient of friction between m1 and the surface. Then the other question, now if you have the values for these, you can even plug them in to find the value of this one. Now, in an event that you are asked to find m2 or m1, so here what you can do, or even h, what you can do is, what you need to do is just need to make what you are looking for the subject of the formula. For example, for m1, so here we have, if we cross multiply this one, we are going to get, so mu is equal to m2g minus kh over 2m1g. So if you want to make m1g, if you want to make m the subject, m1, we're going to cross multiply, and we're going to have 2 mu m1g is equal to m2g minus kh. So here it is just a matter of dividing by 2 mu g, also here by 2 mu g. And so this and this will go, this and this will go, and this one will be equal to m1. So m1 will be equal to 2m2g minus kh over 2 mu g. So this is the expression for m1. If it is m2, just make it the subject of the formula also from this, where we have, so here we have m1g. So if you cross multiply, you are going to find that 2 m2g minus kh will be equal to 2 mu m1g. So if you wish to find m2, it is just you take this on the other side, and it will be 2 m2g will be equal to 2 mu m1g plus kh. So you divide through by 2g, also here by 2g, so that this and this will go, this and this will go, and we're going to have m2 is equal to 2 mu m1g plus kh over 2g. So this is how you should go about questions such as this. Thank you so much for watching the video.